Hi everyone. Today's topic is on transformations of quadratic functions. On the announcement, I posted a few pages that you could read before working on this. Also, make sure you watch the video that I linked to on YouTube before doing some of these practice problems. So all I'm doing now are practice problems. I'm going to talk about transformations, how they're related to vertex form that we've worked on in class. Make sure you email me during my office hours if you have any questions. Okay, so given y equals p of x, by the way, this is number 2 on page 204. Sketch m of x, which is negative p of x plus 3. Describe the transformations you performed. So again, let's recall vertex form. Vertex form is f of x equals a times x minus h squared plus k. Another way you can write that is y equals a times f of x, minus h plus k. These are both the same thing. So if you're wondering why this doesn't have a squared, it's because the function p of x is a quadratic function. So when you apply transformations, they just called it m of x, which is m of x is still a quadratic. It's still going to be a parabola. Okay, so what I'm going to do is I'm going to rewrite m of x right under m of x is equal to negative p of x plus 3. So the first thing to do is identify your a, h, and k values. By the way, the book uses other letters. I'm going to stick to A, H, and K. So you could follow the same thing on the YouTube video that you saw. A is the number in front, so that's going to be negative 1. H is inside your parentheses, but remember it's not exactly how it is inside. If I set this equal to 0, it would give me negative 3, and the K is outside. I don't have a K, so I'm going to put 0. Next step is to describe your transformations. Sorry, my phone. The next step is to describe. So my a value is negative 1. If you have an a value that's negative, that's going to give you a reflection. So I'm going to say this is a reflection across the x-axis. If the number was something like negative 2 or negative 5, on top of it reflecting, it's also stretching. And then if it was a number like 1/2 or 0.2, a number smaller than 1, it would be a compression. But because it's just 1 doesn't change the size. It's not going to dilate the function. Instead, it's just going to reflect the function. Keep that in mind. Our h value is negative 3. So that means that's going to be a horizontal shift. And that's going to be a horizontal shift to the left because it's negative 3 units. My k value is 0. If you ever have a value of 0 for h or k, you don't have to talk about it. You don't even have to write it down. And then if you ever have an a value of just 1, that's not affecting your function. There's no reflection. There's no dilation. So you don't have to mention it. Next thing to do is graph. Start at your vertex. From the vertex, I'm going to shift to the left 3 units. So I'm going to move over 1, 2, 3. That's going to give me my new vertex. And then so I've done the horizontal shift. Now I need to reflect across the x-axis. And that's going to look like this. So I'm going to take it and reflect it over, and that's what my function looks like. Let's try another one. So let's try 3a and 3b. So same thing, go ahead and identify your a, h, and k. My a value is 1/2, h is positive 2, k is positive 3. Okay, so I'm going to write that on the side and talk about them. A is 1/2. There's no reflection because it's not negative, but it is less than 1. If it's less than 1, it's a vertical compression. And that's going to make the graph look wider. Okay. My H value is positive 2. That's a horizontal shift to the right 2 units. And I do have a K value this time. My K value is 3. So I'm going to say K is 3, and that's a vertical shift up 3 units, and it's up because it's positive. From here, this time it didn't give me, actually it did. It said my f of x is x squared. That's the parent function. The parent function is concave up because it's positive in the front. It has a positive a value. It's not dilated. The vertex is at the origin. So the parent function looks like this, okay? I'm transforming the parent function. So when you apply these transformations for this problem, you're going to start at the origin, just like the last problem we started at the vertex. This one we start at the origin. I'm going to move horizontally first. So I'm going to move 2 units to the right. So 1, 2. From there, I'm going to move my vertical shift, my K value, which is 3 units up. 1, 2, 3. That's my new vertex. Okay, so here's my vertex. From here, I'm going to apply my compression. So my compression is a vertical compression of 1/2. That's going to make my graph look wider. So it's going to look something like this. Make sure it's still curved like a parabola. That's it. That's part A. Let's try part B. For part B, you're going to do the same thing. I'm going to identify my A, H, and K. A is -3. H is -1 because it's positive inside. And my K is +1. Okay, so A, H, and K. Then I'm going to talk about them. So A is negative, so it's a reflection across the x-axis. And the number is important too. So this time it's a 3, which is larger than 1. That means it's also a vertical stretch. Okay. My H value is a horizontal shift. So for H, I'm going to say that's a horizontal shift. This time it's negative, so it's going to be to the left 1 unit. Sorry, I have scribbles on here. And then my K value is +1. So for K, I'm going to say that this is a vertical shift. It's positive, so it's up 1 unit. So again, start at your origin. Here's my origin. I'm going to apply my horizontal shift. So I'm going to go to the left 1 unit. Okay, then I'm going to apply my vertical shift. I'm going to go up 1 unit. And then that's my new vertex. From my new vertex, I'm going to reflect and apply a vertical stretch. So my graph is going to look skinnier. And it's going to look, whoa, it's going to look something like, that's terrible. Let me redraw that. It's going to look something like this. Okay, and it checks out. If you look at this function in vertex form, okay, you could see the vertex. So the vertex would be -1, +1 by vertex form, and that's exactly where it is. So it all checks out. Your homework is essentially this. Let me show you a problem on your homework. It's the worksheet that I've attached to this announcement. You could print out the worksheet, do it on there, or you could do it on a separate sheet of paper. You're doing all the odds starting with number 9. So I'm going to do some of the evens for you. I'll do number 10. So for number 10, it wants you to describe the transformations. Again, identify your A, H, and K values. So A is 1/3, H is -1, and K is 0. Remember, if K is 0, you don't have to talk about it. If H is 0, you don't have to talk about it. A is 1/3. So for A, it's less than 1. I'm going to say it's a vertical compression. H is -1. So it's going to shift horizontally. H always shifts horizontally. So horizontal shift, it's negative. So left 1 unit. K is always a vertical shift, but we don't have one, so you don't talk about it. That's what you do for the first set. The next set, 13 through 15, you have to write your own quadratic equation. So for example, number 14 says, write a quadratic equation with a vertical stretch of 2. It should reflect across your x-axis and be translated 3 units up. What I do is I look at these transformations and identify a, h, and k value. So for example, the translation up, I know that's going to be a k value. So I know that k is going to have to be positive 3 since it's going up. If it's reflecting across the x-axis, I know a has to be negative if I want it to reflect. And then if it's a vertical stretch of 2, I know that a has to be 2. But because it's negative, it's going to be negative 2. So when I write my answer, I'm going to take all of this, put it together, and say y is equal to negative 2, because that's my a, times x. And by the way, I'm writing this in vertex form, which is this to remind you. I know k is 3, so I'm going to put plus 3, but I don't have an h value, so you don't write one, okay? If I don't have anything in parentheses, you could drop the parentheses and say y is equal to negative 2x squared plus 3, and this would be your answer for number 14 on the homework. For number 16 and 17, it's like the example that I showed you in the book. You're going to identify the transformations and you're going to sketch it. Notice that for all of these, the parent function is f of x equals x squared. That's your parent function. So that means you just start at the origin. If you have any questions, again, let me know during the office hours. I hope this was helpful.